Welcome. Today we're going to be doing question one of May-June 2024, May-June 2024, paper 2 on physics. So, question one starts and goes as thus. It says, use the SIV's unit to show that the drag coefficient has no unit. So this is the main statement here. That the drag coefficient has no unit. The drag coefficient has no unit. So now the drag coefficient here, the question has told us something. It says drag force FD. So when we're doing with a units question, it's always good practice to start by writing the units of everything. So FD is a force. So we know from force being mass times acceleration, that's kg s minus 2. You get a mark for this. This is a 3-mark question. You get a mark for writing this. Then subsequent marks are gotten from reading these parts of the question here. Subsequent marks are gotten from reading this part of the question. Now they said A is the cross-sectional area. Area, of course, is going to be meter square. And it's good to keep everything in SI units, so meters, kilograms, seconds, and the likes. Now, rho is density. Density is mass over volume, so that's kg per meter cube. That's cube. And then C is drag coefficient. Okay, they also have velocity here as well. Velocity, which is meter per second square. Now, C is drag coefficient. So, C is the constant called the drag coefficient. So we should show that C has no unit. Okay, fine. Remember, when we're doing unit questions, the whole numbers don't matter to our case. So we can choose to ignore it, and basically we can write the whole statement as FD equals to C rho A B squared. Now FD is kg meter per second. We keep C, and then we said rho. Actually, rho is kg m minus 3. A is m squared, and V is V squared, so that's going to be m squared s m squared s minus 4, I believe. Oh no, I made a small mistake. Velocity is meter per second, so it's m squared s minus 2. Good. Now we can consolidate both sides. Kg m s minus 2 kg. So you see, kg has nothing to cancel with, so we keep kg, and we say kg. M minus 3 and m, this is basically going to turn into m4. M4 with m minus 3, so it's basically like doing m4 over m3. You'll be left with an m, so you can put the m here. And then s minus 2 remains the same because it has nothing to cancel with. So what we observe is that these two are the same, and they can essentially cancel out if we choose to divide it. So that cancel out shows us that C has no unit. So we now have to write a statement to finish it off and say, you can say units cancel out, therefore C has no unit. And then you get your 3 marks. I'm very sure you get a mark for this. You get a mark for writing all of this, and then you get a mark for doing all of this as well. Good. Now, next question. The next question says that figure 1.1 shows a sphere falling at terminal velocity. Terminal velocity is a very important word here in this question. Terminal velocity. Now, assume that upthrust in the sphere is negligible. Assume that upthrust is negligible. Good. Draw and label arrows to show the direction of the two forces acting on the sphere. Okay, good. So, what forces could be acting on this sphere? Now, in this sort of question, we're looking at what forces could be acting on the sphere. Of course, the sphere has mass, so therefore, since it's in air, the force of gravity acts upon it. And that force of gravity, due to its mass, is its weight. So, and that acts downward since it is falling, as the question has said. So, since it's falling, we have its weight acting downward. They said label. So, we can label it, we can label it, we can label it weight. And it's straight down. Now, the next force would say, since they said upthrust is negligible, because upthrust would have also been an upward force, the next force is drag force. Now, drag force, you can label it FD or you can call it drag force. Now, it's called drag force because it's resisting, it's like friction due to air, due to the fluid around it. So it's like the ball, there's um there's there's air moving around the object, streams of air, streams of air, streams of air. And these streams of air are going to be exerting an upward force on the object called drag force. So yeah, there's that. So those are the two forces. All you need to draw to get your marks in such a question would be to draw this arrow here and this arrow here, vertically downward and vertically upward. And that is all you need. Now, they said the mass of the sphere is this. Now, this is not in SI units. Calculate the drag force acting on the sphere. So, good thing. Calculate the drag force acting on the sphere. The question, like I said, terminal velocity is the key to answering this question here. Because it has terminal velocity, something happens. At terminal velocity, it means it's moving at a constant speed, meaning that there's no resultant force acting upon the object. That tells us that the upward force is equal to downward force. And in our case, that tells us that W is equal to FD. And that's a mark already. Now from there, we know that W is mg, so we say mg is equal to FD. And therefore M, which is the mass, 49. Now we see it's over 1,000 because that's in grams, we need it in kilograms, times acceleration due to gravity, which is 9.81. And then you get your answer to be 0.48. Remember, two significant figures since the question, all the units were given in two significant figures. So now the next part of the question is to solve for to find the drag coefficient. Good. Now to make our life easier, I put the formula that we're given in the first page because we reference it here. Now we already have our FD, so best practice is to write down all your variables, what you're given, all you're given basically. So we have FD as 0.48. Now they said terminal velocity of 25 in SI base units. SI base unit is the meters, seconds, and all of that. So we know that our V is 25, and this okay. And velocity in 25 meters per second. Density in 1.2 kg meter cube, and then diameter being 0.060 meters. Now, firstly, for finding drag coefficient C, so one thing I would usually start with is to make C the subject of formula so that I see what I'm working with. So that will be 2FD all over rho AV squared. So now we know that we need area, but we're given D. So we know area is pi D squared over 4. So that's going to be pi 0.06 squared over 4. You can impute this and then basically you find C, put it in your formula, 2 times 0.48 all over 1.2 times pi 0.606 squared. 4 times that by v squared, v being 25. When you input everything into your calculator, you get your c as 0.45. Remember, c has the units from the initial part of the question. And with that, we are done with question 1.